So the warm up, and I am recording. So there was this was typed weird. So I know to fix it for the future, but this actually should have been the first one that you reviewed. So let's review this together. When we're comparing the used car price to the original sale price of the car, what would you expect that graph to look like? So anytime you are comparing two variables, one of them is independent and the other one is dependent. So what do you think depends on what? Do you think that the used car price depends on the original sale price? Or the other way around, the original sale price depends on the used car price? Well, it sounds like it makes more sense. Lauren?
The used price, depends on the original price.
Okay, good. Because wouldn't a used Rolls Royce still cost more than a used Toyota? Do we know what a Rolls Royce is? Or a Lamborghini, another expensive car? Yeah. Those cars, even used, would still be worth more than a used Toyota or a used Honda or something like that. So my one that is independent, my original price would go on my x-axis. My used car price would go on my y-axis because it depends. Cars that were originally more expensive are probably still going to be more expensive used than other cars. So how would you expect it to look? Do you think it would be linear? Do you think it would go up or down? It'll be a very long lesson if we don't get more participation. So as the original price increases, let's say this is $10,000 for the original price, 20,000, 30,000. Do we expect the used car price to also increase or also decrease? So I agree. The graph probably looks something like this. Do you think that that's strong or weak? Strong. So it's strong if it looks linear. And again, this isn't your number one that's here. It's the one that for some reason is in the instructions. Used car price to original sale price. It's strong. Would you say that it's positive or negative? Positive, because it's going up from left to right. So that's what I'm looking for in each of these. Is it strong or weak? And is it positive or negative? So then table 8. When we compare the used car price to the number of cup holders in the car, do you think that there's a relationship there? Okay, so for this one, did you say no correlation or did you say weak correlation?
Probably a weak.
So for this one, you could have said weak or no correlation. And I don't know, maybe cars with more cup holders are slightly more valuable than cars with less. I don't really know. But you could say be positive in that case if you agree with me, but you need to be able to justify it either way. I don't think the cup holders play a big factor into the price of the car. So I would say weak or no correlation. The graph would probably look something like this, where there's not really a consistent pattern. Can't tell if it's going up or down. All right, table 9. What about used car price and number of oil changes the car has had? What do you guys do? Yeah, used car price compared to number of oil changes the car has had. Do you think that would be strong, weak, positive, or negative? Well, that's not an option. Yeah, on your test, for example, like if you look at on your practice test, 2A, what's the relationship between? You need to tell me, is it strong or weak? Is it positive or negative? So what do we expect? I don't know how much you guys know about cars, but how often are you supposed to change your oil? I don't know about, I know like every 5,000 miles. So now that I told you that, about every 5,000 miles, you should be changing your oil. So do you think if they have more oil changes, that the used car price is higher or lower?
Lower.
And why do you think that, Benji? I'm not saying you're wrong. But if we have more oil changes, do we expect the car price to be higher or lower? I feel like you could justify it either way, but. Okay. Ryan?
Well, because it shows how much more the car has been used.
Okay, good. That's what the book said too. So would you expect, so you probably expect it to look something like this. So would you say that that's strong or weak? Strong, because it still looks linear. We would still expect it to be pretty linear. Would you expect it to be positive or negative? So strong, negative. And you could say because more oil changes equals more use, which if you're buying a used car, you probably don't want it to be used that much. And that's what the book says too. Earlier when we did this problem, I was thinking of it more as like there's some people that just never change their oil, or they wait way too long to change their oil. So I was thinking like more oil changes means that it's like better maintained. So you could make an argument either way, you just need to justify it. Okay, so where am I? Table 1. Used car price and number of miles that the car has been driven. Describe that relationship. Or can you tell me how the graph would look, you think?
I think it would be strong.
Okay, so that means it would look something like this. So that means as the number of miles increases, the car value is decreasing. Do you guys agree with that? So I agree. I always have to draw it out. I'm a more visual person. So once I can think about what the graph should look like, because yeah, more miles, less value. I see that now it is strong because that's a strong linear correlation. And is it positive or negative? Say it again. Okay. Strong negative. Questions on that? Negative because it's going down from left to right. Strong because it looks like a straight line. Good. All right. Now that's all about correlation, relationship, association, whatever word you want to use. That's seeing how close like two things are to having a relationship to each other. Today's lesson, which let me pull up the slide, is about what we call causal relationships, meaning like cause and effect. So today we are going to look for connections between two variables and analyze whether or not there is a causal relationship. So like, again, causation, cause and effect, saying that this for sure caused that. So if I could summarize this entire lesson in a few sentences, very rarely is there causation. Sometimes there is. For example, and I'll give you some examples later, but causation has to be like scientifically proven that nothing else could cause this. All right, so we're seeing if that is true between a bunch of different variables. So I'm recording right now. Last year, I explained it a different way. If you want to take a view at that video from last year, some good examples. Puzzle piece is less than 9. And there's all the study guides available for your test that you're taking on Wednesday. So they're all available now. This one's been available since last week. These ones I made available over the weekend. So the first one you have to do is 100 class points. It's worth more than all of your homework for this unit combined. So if you're prioritizing what you need to get done, especially to be ready for the test that's on Wednesday, do the first one. Worth way more points than all your homework for this unit combined. Second one is the paper you picked up today. I am checking this tomorrow during the binder check. So try to have this ready by the time you come in. That way, you don't have to worry about finishing it and uploading it to Schoology, but that is an option too. It's not ready by the time you come in tomorrow. And then the last one, the optional study guide, it says optional and extra credit in the title. You can get up to 100 extra credit points by doing that. So again, prioritize what you need to. I know I just told you you also have a lesson 9 practice, but this is 10 points. And then combined, this is like 250 points. So prioritize what you need to. These are all closely aligned to the actual test that you're taking Wednesday. If you're not understanding something, you should ask tomorrow when you have time to work on it. Any questions about that? So in the slides and in Schoology is the list for what you should have for your binder check. Binder check's always day before the test, so that means binder check is tomorrow. Only 7 pages. And then your practice test is what I'm checking tomorrow, which should leave a lot of extra time to go over questions you have from the study guide. So it'd be better if you like engage with it prior to coming to class tomorrow so that you can ask those questions. I told you way in advance, maybe even like over a month ago, that we would test for unit 3 and retake it before Thanksgiving break. And we're here. Right, next week is Thanksgiving break. So Wednesday we're taking it. Friday you are retaking it unless you get an A the first time. And if you know you're not going to be here Friday, then I guess just have a good Thanksgiving break. I don't know if you'll do better when you return from break, but like you'll still get that opportunity to retake it. So whatever, study, do whatever you need to do, but you only get one retake. So make it a good one. Questions on anything I just said? Okay, so then you have a bunch of examples on your paper, really only 4, of 2 things being compared. You're going to see why those things have a strong relationship. So these all have strong relationships. They're all really close to the line of fit. You're going to write a sentence or 2 talking about why. So the first one, during the month of April, Elena keeps track of the number of inches of rain recorded for the day and the percentage of people who come to school with rain jackets. So you could say something about why do people come to school with rain jackets when it rains more. All right, the more it rains, the more people need rain jackets, something to that effect. But you're doing it for all 4 of these things. So why do those variables have a close relationship? Talk about it in your groups. If you finish early, try to see, is there a cause and effect relationship going on in any of them? So do that. Since there's 4 of them, I'll give you 4 minutes. Yes. Right, something. The more it rains, the more people need rain jackets. right? Like if you wake up in the morning and it's like lightly sprinkling, you might not necessarily bring your rain jacket. I don't even know if you guys own one, but you might not bring your umbrella. But if you go outside and it's raining really hard, then you're more likely to bring your rain jacket. So that I would agree with it. Now, do you think that the rain caused them to bring their rain jacket? Would you say that there's a causal relationship there? I would lean toward yes as well. Maybe later you'll change your mind when I give you like the real definition of causation. But yeah, what else caused them to bring it? All right. People still might wear a rain jacket for like style. I don't know. I wear army pants sometimes, even though I'm not in the army. Like there's reasons that people wear stuff other than for like necessary needs. But in this situation, yeah, there's probably some causation there. Questions on that? Okay, so then the second one, table 2. A school book club has a list of 100 books for its members to read. They keep track of the number of pages in the books the members read from the list and the amount of time it took to read the book. So why do you think those are closely related? Okay. So I would kind of revise that slightly. I would say the more pages there are, the longer it takes to read. Wouldn't you guys agree with that? The more long a book is, the longer it takes you to read. So that's what I would say. So yeah, as more time passes, there's more pages that they're having to read, but really it's like the other way around. The more pages there are, the longer it takes to read. Make sense? So would you say that there's cause and effect there? Is it the pages that are causing them to read longer?
Yes.
So there's more of them. Are there outliers? Maybe. But if it's the same person reading the same book, it's probably going to take longer to read the longer book. All right. Table 3, number 3. Okay. Number of tickets left for holiday parties at a venue and noise level at the party. Why is that a strong relationship? Okay, so more people attending the party, the more noise we expect, right? So what this one's comparing, so say that you're in Stuco and you expect there to be 200 people at homecoming, but really only 100 of them show up. Wouldn't you expect it to be quieter than what you expected? All right, but it's not the fact that we have a bunch of tickets remaining that it causes the noise to be quieter. It's the fact that we don't have as many people attending. Does that make sense? Now, couldn't there be like a ton of people and it still be relatively quiet? It could. So I wouldn't say that there's causation in this one. Things can be strongly correlated without there being a cause and effect. All right, it's not the tickets that cause it to be quieter, it's the fact that there's fewer people. But even then, you can have a really small party and it be louder than like other bigger parties. Make sense? Okay. Now, the height and score on a test of vocabulary for several children, ages 6 to 13. So table 4, why is there a strong relationship between height and vocabulary test score? So do you think that, like, for example, in this class, do you think the taller kids are the smarter kids? Does height play into like how smart you are at this, like when we just talk about our class? No, but why does it make a difference in this children that they observe? So table 4, do you want to try that again? So from what you said, it's not necessarily that the taller kids are the smarter ones. Why does that make a difference in these kids that we looked at? Because they're older, okay. So when we look at kids ages 6 to 13, some of you were probably even 13 when you started high school. Wouldn't you say that you have better vocab than a 6-year-old? So that's why we're seeing a relationship there. So the taller kids tend to be older. Not all the time, but the taller kids tend to be older, therefore, or thus, since I don't have room, have better vocabulary. That's why they're strongly correlated. Is there causation in this one? Couldn't you have, say, like a 10-year-old that has better vocabulary than a 13-year-old? Yeah, so there's no causation there. Your height doesn't make you score better on a vocabulary test, not necessarily even your age causes that, but that's the trend. So I would say in this one, there's no causation. Questions on that? Okay, we're kind of running out of time a little bit, but I do want to at least tell you my one example that I think to me makes the most sense. So in the summer, the temperature increases. Will you guys agree with that? Okay, so as the temperature increases, what's something else that tends to go up in the summer? Air conditioning. So yeah, let's use that. So the air conditioning bill, the AC bill, tends to go up in the summer. Guys, listen. This is so important. I'll give you time to pack up. I promise. I will not let you out late. But if you guys keep packing up and I can't hear myself, then I will let you out late. So just everyone stop. Listen. So when the temperature rises in the summer, so does your AC bill. You know what else rises in the summer? The amount of sunburn. So in each situation, you can say that there's a correlation and a strong positive one, but only one of them has causation. You can even say that between these two, since they both go up in the summer, that there's a correlation between these two. But do you know anything else that causes a sunburn other than the sun? Or is it only the sun that causes a sunburn? So since it's only the sun that can give you a sunburn, there's causation here. Since you could still have a low AC bill, maybe you never use your AC all year round, there's not going to be causation between the sun and the AC bill necessarily. That's not what's causing it to go up. The fact that you're using it more. There's definitely no causation between the AC and sunburn. Even though they're strongly correlated, The sunburn isn't making you turn up your AC. Your AC isn't giving you a sunburn, so that's the difference between correlation and causation. Questions on that? That should at least help you with one question on your test. Otherwise, just when in doubt, there's very rarely ever causation.
Have a good day.
You too.